In this video, we're going to learn how to do parametric differentiation. We are told that parametric equations of a curve are x equals to 1 minus cos theta, y equals to cos theta minus 1 over 4 cos 2 theta. So we're going to show that dy dx equals to minus 2 sine squared I have theta. Now, in order to do this, remember that we can be able to find the x d theta. So meaning you're going to differentiate the first parametric equation in terms with respect to theta. So in order to differentiate this, we know if you differentiate a constant, you are going to get actually 0, because if you differentiate 1, you get 0. Then if you differentiate cos, you are going to get negative sign. And ideally, what will happen there is that a negative and a negative will give us positive sine theta. Next, right, so this becomes sine theta. The next thing we're going to do first, we differentiated the constant, and also you differentiated the second term. This became 0, and this became sine theta, because there was a minus there, and negative over sine now becomes positive sine theta. Now, the next step we're going to go is to find dy d theta. We're going to differentiate y with respect to theta. If you differentiate cos theta, you're going to get negative sine theta. Now, if you differentiate cos 2 theta, we're going to use chain rule at that particular point. So the first thing to do is to differentiate cos. That's going to give us negative. Without looking into 2 theta there, just differentiate a cos function, and that is going to be negative sine 2 theta, right? 2 theta, the way it is. Then now the next thing is to differentiate 2 theta itself, and that becomes 2. Then this is going to simplify to negative sine theta plus a half sine 2 theta. Okay. All right, so let us now find dy dx. This is going to be dy d theta divided by dx d theta, because you can see if you are having this, when you change a division to a multiplication, the other side is going to be d theta over x. You can see now theta and theta will cancel out. You end up having dy dx. So meaning, for you to find dy dx, you are going to take dy d theta, you divide the expression you got from dx d theta, so that we can be able to get our final answer. So we're going to divide it like that, and then we can now change sine 2 theta using double angle identities. And if you have not checked how to perform double angle identities, you can check a video that I've done beyond that. So this one is going to become what? It's going to reduce to minus sine theta plus a half sine 2 theta is going to become 2 sine theta cos theta, so that we can be able to divide by sine theta here. And if you cancel that, you're going to remain with this particular expression with sine theta at this given point. So if you can simplify this further, we are going to remain with cos theta minus 1. But cos theta minus 1 is equivalent to what? Let us check double angle formulas. So let me write it here, so that cos 2 theta equals to 1 minus 2 sine squared theta. So which means that our expression can be reduced to, so if you're having cos 2 theta equals to 1 minus 2 sine squared theta, if you write cos theta, a half of cos theta is actually theta, which is going to be equal to 1 minus 2 sine squared a half of that angle that we are having there. Yeah, because if you are having theta on the left hand side, on the other side is going to be a half of that particular angle. So which means that cos theta minus 1 is going to be replaced there. So this is going to imply that if you take 1 on this point where we have an arrow, if you take 1 to the left hand side, we are going to have cos theta minus 1, which is exactly the expression that we were having. So which means that we can rearrange this particular part. Let us rearrange it so that we can make a lot of sense, and that's going to be theta. So this part is the one that we're going to replace, and finally our answer is the expression that we were given. Now you can see we have used parametric differentiation in order to differentiate the parametric equation of that particular curve. If you have gotten value from Proflan YouTube channel, consider subscribing so that anytime we're going to upload further tutorials, you'll be notified. See you in the next video.